Okay, so now we have binomials, and let's look at these. Let's observe what's happening here. So first thing we want to look is, all right, we still have two binomials multiplying each other, meaning we have two terms inside of each parentheses. And what do we notice? Hopefully you notice and see that you have opposite constants, that you've got -10, +10, -4, +4, +6, -6, +5, -5. How's that going to affect our solution? What it produces, the term that it produces? Well, if we don't see it automatically, we can go through FOIL, firsts, outsides, insides, and then lasts. So if we write that and simplify it, you end up with p squared minus 100. Let's do the next one. Firsts, outsides, insides, and lasts. What are you left with? And at this point, we should notice that our outside plus our insides, they're going to cancel. They end up being opposites as well. Positive 4v, negative 4v makes 0. So we're left with our first and our last. So our inside and our outside will cancel, so we're left with first times first and last times last. So knowing that, what would we expect to get from x plus 6 times the quantity x minus 6? Well, our first times first and our last times last. What would we get for number 4? We get our first minus our last. And if we look at each of these solutions, we should also start noticing a pattern. We should notice that we have a perfect square and a perfect square, 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 perfect square, and a perfect square. The second thing we should notice is that each of these is subtraction. And then the third thing we should notice is that there are two terms, two terms, two terms, two terms. And if we look at the title of this section, the difference, which means subtraction, it's the difference of squares. And we should notice that we have two squares. So we are subtracting two squares. That's the difference of squares, is you're subtracting two perfect squares. So when you have binomials that are opposites, we call them conjugates. And when you multiply conjugates, you're going to produce the difference of two squares. You're going to have the first, so technically it produces f squared minus l squared. F standing for firsts, L standing for lasts, and you're going to subtract it. So it's the difference of two squares. So let's take that and now let's reverse it. So we want to see if this is the difference of squares, whether when we factor this will produce conjugates. So what are those three characteristics? The three characteristics was, number one, are there two terms? The next one is, are we subtracting those two terms? And then the third thing is, are both perfect squares? So we want to look at this starting expression. Does it have two terms? Yeah, it has two terms. Is it subtraction? Yes, we're subtracting those two terms. And are both of these perfect squares. X squared is a perfect square and 16 is a perfect square. So what would the conjugates be? Well, we know that it would be the square root of both of those. So the square root of x squared gives us x, the square root of 16 gives us 4. And then we need to have conjugates, meaning they have to be opposite. Now, it doesn't matter if you wrote x plus 4, x minus 4, or if you started with the negative. So I would be okay with either of these. They just have to have opposite signs. So those are the same answers. There's no difference in how much it's correct. All right, so let's look at this next one. Does it have two terms? Yes. Is it subtraction? Yes. Are both of the terms perfect squares? Yes. So we would write m plus 6 and minus 6. About k squared minus 100. Oh, sorry. Messed up my microphone. K squared minus 100. Two terms, subtraction, both are perfect squares. K minus 10, k plus 10. And then the last one, x squared minus 4. Yep, two terms, subtraction, both are perfect squares. So I know that if I factored that, the factor of that, the two binomials that would produce that would be x minus 2 and x plus 2. So let's add a little flavor. What if my variable had a coefficient? So notice these are still conjugates. They're identical, but with different signs. So we know that the inside and outside, the inside is going to give me 24b and the outside is negative 24b, so they're going to cancel. So I know I'm going to end up with just my firsts and my last. So that's going to be 9b squared minus 64. I look at number 6. They are conjugates. So I'm going to get 49x squared minus 64. Number 7 are conjugates. I get 81n squared minus 4. And number 8 would produce 25b squared minus 1. I like that one because of the 1 part of it. Good. So notice each of our solution, two terms, subtraction, both perfect squares. So they're still producing, when you multiply conjugates, you produce the difference of two squares. So what if we start with, and it says to factor this, can you tell me what those conjugates would be? But you got to make sure that they have those 3 criteria. Is it two terms? Is it subtraction? Are both of the terms perfect squares? Yes for number 13, so I can factor that into conjugates. And that would give me 3v minus 5, 3v plus 5. How did I get those numbers? Square root. The square root of 9 is 3, the square root of v squared is v, square root of 25 is 5. So I really got to know my perfect squares. So 16b squared minus 9 would be 4b minus 3, 4b plus 3. 81x squared minus 100, that'd give me 9x plus 10, 9x minus 10. There's no reason why I put positive first or negative first. I'm just changing it up just so you know that it doesn't matter which one comes first. 49n squared minus 16 is 7n minus 4, 7n plus 4. Good. All right. The last thing that we need to discuss is what if we multiply a variable with a different exponent, with an exponent. So what if I have n cubed minus, we haven't done, let's do 11, and n cubed plus 11. So those are conjugates. So I'm going to square my first. So that becomes n to the 6th minus 121. My inside and outside still cancel, but n to the 3rd times n to the 3rd is n to the 6th, not n to the 9th. We multiply bases with exponents. when we multiply terms with like bases, we add their exponents. So that's a very interesting one. Okay, so that doesn't change anything. What if, and here's that crazy one, here's the third level of a question. What if I have x to the fourth minus, let's do 81. So does it have the three characteristics? Does it have two terms? Yes. Is it subtraction between the two terms? Yes. Are both perfect squares? Yes. So let's factor that. And most students would stop here. That's the correct next step. This is what that next line should read. However, we should notice something unique about this. This is what I call dead on the street. That's difference of squares, okay? And we know it's difference of squares because it has these three characteristics. And most students stop here, but unfortunately they don't see that this can still be factored also. So the conjugate of the starting problem is also a difference of squares. This is not, because this is positive. It doesn't have subtraction. So we cannot factor that. That needs to stay. But we need to see that this holds all three characteristics also, and both are perfect squares. So I would leave this, but I can factor this. That factors to x minus 3, x plus 3. So that is a tricky question where you have a difference of square and one of its conjugates is also a difference of square. So be careful of that one. That's a tricky one. Come and see me if you have questions.